Hi everyone, welcome to my video presentation of my final project. Here I'm trying to build a model to categorize the spending habits of students, and I'm Mayunzu. So I got this data from Kaggle, which records financial data representing the spending habits of 1,000 students across various demographic groups and academic backgrounds. As you can see here in the dataset, we have 18 features and 1,000 instances in the dataset. You only see 7 variables here because I dropped the ID column beforehand. So all the features are a mix of numerical and categorical variables. The target variable here is the preferred payment method. What I'm trying to do for this project is I want to build a classifier which can help me predict students' preferred payment method based on their demographic traits like their age, gender, major, things like that, and their spending habits such as how much they got from monthly income, how much they got from financial aid, how much they spend on tuition, housing, food, etc. So the target variable here has 3 classes, which is cash, credit, debit card, and mobile payment app. As you can see here, the distribution of these 3 classes are quite even. The cash has 31%, the credit debit card has 34%, and the mobile payment app has 35%. Even after I split them into train and test the data, you can still see that the distribution is around the same, between 30% to 36%. But this to be said, my classification task still failed because of the quality of the data. I started realizing the problem after I did several runs of model construction and development, and then I consulted TA Ayushi and Professor Azara. They confirmed that there's something wrong with the data, but this is still a valid lesson for me because I started seeing some red flags after I reviewed my code, which I should have been caught earlier in the process. So I want to share the red flags that I met with you. And also, to prove that my model construction and development method actually worked, I did a second version of my final project, which I'll be talking about later. So here's my code. After I did an overview of my dataset, I started exploring individual features. First, I explored the categorical features because I want to see how many classes are contained in each feature, and then explore the numerical features because I want to see what distribution they're like, what kind of ranges they lie in. The table is kind of hard to read, that's why I also plot a scatter plot here. And after that, I detect the outliers using the index. As you can see here, there's not any outliers in the numerical features, that's why I leave it alone. So after that, I started doing some correlation analysis among all the features so that I can tell if there's any strong association among them, and turns out there's not. As you can see here, all the association is quite weak. And in retrospect, I feel like this should be the first red flag that I should notice, because this shows like even between the target variable and the predictors, there's very, very weak association. After that, I did a chi-square test to test if there's any association among categorical variables. But as you see here, all the p-values are bigger than 0.05, which means that all the categorical variables here don't have a strong association with each other. So this might be another red flag, but at least at that point, I thought, okay, good, great. Like, I don't have any features that's heavily dependent on each other. So maybe I don't need to eliminate any feature while I'm building the model. So after that, I also want to see a distribution of the numerical features to see if they are, normal distributed or skewed. And you can see here they are quite even. So this might be another red flag that I should be caught on, because the distribution is just so perfect. Like, how can they be so perfect? So after I started realizing there's something wrong with the data set, I went back to the Kaggle page and then noticed they may add a sentence in description like all the data is entirely fictional. I guess maybe that's why the data distribution is quite perfect. But anyways, then I head into the data cleaning and shaping process to avoid any data leak. I split all the data into train and test sets. I set one set for the KN, one set for decision trees, and another set for the SVM, which will come up later. After I split it, I test if there's any missing values, and there's none in the train, both the train and test data set. For demonstration reason, I just write up a code here to impute the missing data with median. And then after that, I started normalizing all the numerical features using z-score standardization. As you can see here, train set, data set, and then I used one-hot encoding for the gender and the major categorical features because they are nominal and they contain more than 2 classes. And I just assign numbers to the year in school categorical feature because they are ordinal. So I just assign freshman to 1, sophomore to 2, etc., etc. I did the encoding separately for train and test set again. And then I add all them together for the SVM model. Okay, so first I built KNN. I chose KNN because I'm aiming to build a classifier. The majority of my predictors are numerical features, and I don't have ton of predictors, so I don't need to worry about the slow classification phase. So I set up my original K to 26 because there are 700 instances in training set, and by default the K value should roughly equal to the square root of the instance number. So that's why I set it to 26. And as you can see here, I used the confusion matrix to test it out, and the accuracy rate is quite depressing. It's only 31%, which is very low. And more alarming is the kappa is negative, which means there's a agreement between the prediction values and the references values. And looking closer, about 30% of the debit card being predicted correctly, 37 of cash, and 28 of mobile payment app. So there's like no dominant cause has been corrected, predicted, which means could be, something's wrong. But at that time I thought maybe because my K value is not setting good, so that's why I try to improve my model performance by trying out different K values ranging from 25 to 35. But still the accuracy rate is quite depressing. As you can see here, it ranged from 29.7% to 32.3%. So it's still quite low. But anyways, that time I thought maybe KN is not right. So I go ahead and started trying the decision trees. I used the C5.0 package. As you can see here, the decision tree accuracy rate is a little bit higher. It's 33.7%, and the kappa score is at least positive this time, but it's very, very low. It's lower than 0.01, which shows the agreement between the prediction values and the references values are quite low. But still, I try to see, is this kappa value like constant here for this decision tree model? So that's why I use the K-fault cross-validation here to try out 10 times of the 10 faults to see if the kappa values stay positive. The answer is No. The main kappa value is still negative 0.02, which is quite alarming. I should have caught it earlier in the process. But anyways, I go on. I started the model tuning. So I tried out different window setting and trial setting to see if I can get a better performance for the model. And no, the answer is still no. So the highest one that I got here is when I set to no winnowing and set trial to 5, which helped me to get a little bit higher than 33.5% of the accuracy rate. Still quite low. And then I add mistake cost to the decision tree model because I noticed that there are like more cash being categorized as mobile payment app. There are more credit debit card being mistaken as mobile payment app. So that's why I add the mistake cost accordingly, hopefully to try to twist the model a little bit more. And yeah, it boosted a little bit to 35.3%. A little bit. If I have to choose one, decision tree might be a better one because at least I can get a positive kappa score here and a little bit higher accuracy rate, but it's just really low. So then I moved to the support vector machines. I build up my model here and I test out the evaluation with the confusion matrix again. So accuracy, not surprisingly, is still 33%, and the kappa score is still negative. So at this time, I'm seriously doubting if there's anything I can do to improve the model, and that's when I started tuning the SVM model. I set the kernel from the linear to the radio based one. So the accuracy rate is still 33.3%. Nothing has been changed. It feels like talking to a wall. And then I set the cost parameter from like 5 to 40, and I tried this out. So, the highest did boost a little bit. Can I say boost a little bit to like 36% when I set the cost value to like 15, but it's still quite low. So after I tried the individual models, I put them together as ensemble. First, I tried the rainforest homogeneous ensemble method. 33%, not surprising. Negative value, kappa value, not surprising at all. But anyways, I'm still trying to see if there's anything I can do. So we all know that in order to we can change this model complexity by changing how many tree numbers they get to reach. So I tried out a bunch of tree values from 50 to 150, and the accuracy rate is still quite stable. It's between like 30% to 34%. Nothing big has been changing. And then I built up a function for the head ensemble, which what I did here is that I just use the prediction from the 3 different individual models that we built before, and we will output the most frequent prediction. Make that as the answer of this heterogeneous ensemble result. So not surprisingly, the accuracy is actually a little bit better. It's 35.7%. It's good, but it's still quite low. But I feel like I tried everything, but it still never exceed like 30%. And the kappa value is always like negative, and when it's positive, it's still like really